All right, let's try this again. I apologize if you were trying to listen to the one I posted without sound. If you missed class on the December 3rd or 4th, this is the practice we did during class. If you were there and you're just hoping to hear another explanation of it, then you're in the right place. So in this first set of problems, we were told to find all angle measures, and the properties or the definitions that we're using are the concepts of two parallel lines and a transversal and the angles that are formed by those lines. Now we actually have multiple pairs of parallel lines here. We can tell by the sets of arrows. So these two lines that have two arrows on it, that's marking parallel. These have one arrow, and that is also marking parallel. The type of marking is different because obviously the two pairs are not parallel to each other, but they are intersecting. So since we have two sets of parallel lines, these are going to be able to interchange between being parallel and also working as the transversal. So I think it's helpful in this to try to simplify the diagram a little bit and maybe just focus on one set of parallel lines at a time. I say you could cover something up with your hand or a piece of paper. I'm going to use this sticky note in the Jamboard to do that. So I'm actually going to cover up this line here and focus in on these two lines as my parallel lines, and this is my transversal. I'm a little sloppy there, but I can think of this as one diagram within this larger, more complicated diagram. So when I use those and then I go through my coloring process, my checkerboard, I would mark this one, and this one. Obviously the other ones would be a second color, or you can leave it blank. I'm going to leave it blank because I'm going to use some colors to explain the lines here. So now I can move and I can switch the parallel lines. So now I want to think about my parallel lines, maybe also being these two red ones. But now I'm treating, actually just to connect to the original, we'll do it this way. Now I want to treat these two as my parallel lines and this as my transversal. I could have done it the other way too, but because I've already started with one color, I kind of want to connect it to what I already have. So if I'm moving along this transversal now, I can actually continue with that same blue color, and to finish the checkerboard going this way, I would mark those two angles. If I switch my parallel lines again to be now moving along this as a transversal, so I'm basically back to the red lines, and maybe I'm using these two and this as my transversal, I can finish up with my blue and mark here. And because the two sets of parallel lines, or because I had two sets of parallel lines, they could switch off as being a transversal and a parallel line. In other cases, if the transversals are not parallel and we have multiple ones, we'll see that in a future example, we couldn't exactly do this. But for this diagram, there's only two angles in the whole diagram. So remember, with our color strategy, if it's the same color, then they're going to be congruent. So I know any angle that is blue right now is going to be 83 degrees. And then what happens with the other angle is I have supplementary angles because of starting with this linear pair here. So, or I could even have shown it the other way to connect it to 6. So I have two angles here that form a line. I'll do it in white this time. They form a line here. That's 180 degrees. So I could find angle 6 by subtracting 83 from 180, and for that we get 97. So I know angle 6 is 97. Anything that's left blank is going to be the same measure as angle 6. So, we would end up with angle 1 is 83, So is 4 and 5, because they're all blue. And then all the other blank colored ones are going to be 97. All right, let's move on to seeing this next example. So this is what I was talking about just a moment ago. I have a set of parallel lines. I can see that with the arrow marking. And then I actually have two different transversals here. Now the transversals are not parallel, so unlike the last example, I'm going to end up with more than just two angles, because if I move along my first transversal, I'm going to have two angles. If I move along my second transversal, I'm also going to have two angles. So I'm going to have more like 4 total angles here. So I'm actually going to do that same kind of covering up strategy, and I'm going to cover up this transversal on the right here. So I'm even going to kind of ignore it up there where I'm, if I would be covering some of my angles, but I'm going to focus first on this transversal on the left. And so if I get one of my colors and start coloring here, I would mark 110 and 1. Okay, now as I move up the transversal, if this line wasn't here, this would be one continuous angle, and so would this one on the other side vertical to it. So I know that these combined are going to be 110. If I switch that and maybe think about covering up this one or go along the next transversal, I need to have a new color. So I can mark 50, the one vertical to that. This is also going to be 50. Kind of didn't want to cover up that green, but that would be here and then over here as well. So I do have some overlap that's happening here where the two transversals end up crossing. All right, so I'll do a couple of these with you and then leave some for you to complete. It says find the measure of the angle and give a reason for knowing it. And you don't need to start at 1, you can really start anywhere. 1 seems to be kind of a more simple one, but when we're giving the reason for knowing it, we want to reference the angle relationship that whatever one we're trying to find has with the given angle. So, if I say I can go in any order, I start with angle 3. I see that angle 3 and my given angle 50 form a line, so I'm going to have a 180 degree angle here, and so I know that 3 is going to have to be 130. 130. All right, so my reason for knowing that, and this is a common thing that I see students use as reason, and maybe you've even thought it. You're thinking supplementary. Okay, and that is true. These are supplementary, but when you're giving a reason, you want to think like, how do you know that they're supplementary? So you use the property that they are, you subtract the given angle from 180, but how did you know to even do that in the first place? We actually have a name for when two angles are next to each other, they're adjacent, they form a straight line and add up to 180 degrees. And that is actually called a linear pair. So it is a better answer for us to call those two angles a linear pair, because that's my evidence. How do I know they are supplementary and add up to 180? It's because they are a linear pair. So as you're going through the rest of these reasons, I want to stretch you to think of like, what is the name of the angles, the math definition that leads us to conclude whether the angle is congruent or supplementary. So if I'm finding any angle that is going to be congruent to 50 or 110, my reason should not be congruent. It should be, how do I know it's congruent? And that would be a name of an angle pair. So we have vertical, alternate interior, alternate exterior, corresponding, and those are going to be our reasons for A through D. So you can pause the video and complete the rest of those on your own. I am going to go forward to a new type of problem. All right, so here we have a more simple diagram, and we have x, we have expression, so we're going to need to write an equation. This should look like what we were working on in Unit 1. And so first I'm still going to use my color coding strategy to help me set up the equation. So I go through all of that and I see that 3x plus 16 is the same color as 5x plus 10. The first thing I would want to do, and I wrote some steps over here, is identify the angle pair. Are they congruent or supplementary? These ones are congruent. Now we really only had two different relationships, congruent or supplementary, so it's got to be one of those. And if you think back to Unit 1, we have set up equations for both of those relationships. If two anythings, angles, segments, if they're congruent, we're going to set them equal to each other. If they are supplementary, then we are going to show that. Well, what does supplementary mean? It means that it adds up to 180. So I want to add and equal 180. And that's what I would do with my equation. So these two can be set equal to each other. And then I will complete that equation. And we had a lot of practice with solving these equations with variables on both sides in Unit 1. So you can finish this one. And so pause the video here. I am going to go forward and show you one more. And I'm going to leave you with this one. So try setting this up, figuring out what the angle relationship is, maybe color coding your diagram to do that, or thinking about the name of the angle pair. You know, I didn't mention it in this last one, but these were alternate interior, which we know are congruent. So if we could come up with the name here, it can also help us with identifying whether it's congruent or supplementary, along with the color coding. And just so you know what your answer is when you're working it out, so you can kind of check, you are going to get x equals 30 here. So why don't you figure out how that was done? And if you have any questions on this stuff or need additional practice, let me know. I'll see you in class.